That's interesting.
I don't know. Is there a quick way to mute, unmute, like a shortcut, a keyboard shortcut that you use?
Oh God, I can't remember what it is. It was Control. There is a, it says here, it's Shift Option, no, Shift Command A. Yeah.
Yeah, perfect, thank you.
Yeah. If you hover over the mute button, it shows you in a pop-up. It says mute my audio and then the shortcut.
Perfect. So I think Beth asked, she said she wanted to join, but she's on the kind of, waiting queue, whatever.
Oh yeah, because she'll be just an attendee. I can send her an email. Actually, once she joins, I'll bump her up to the host and it's going to be quicker. Okay, so can you open, let me just post it in the Zoom chat. So just to test that one, this should be the live stream. If you can see,
I'll tweet.
I see the Gopher vision.
Cool, let me get.
Okay, I can see 4 watching now, so that's cool.
Okay, I'll try and.
We might be live at this point, so just, no swearing.
Right, okay, I'll stop swearing then.
I can't actually see it with my personal account yet.
Oh, maybe it's only for those, well, either way. Are we ready to, so Antonio's kicking us off, right?
Yes, cool. Yes. So, are we ready? Did someone tweet the YouTube link?
I can do it while you talk.
Okay. Yeah, because I was supposed to do the tweeting tonight, but anyway, I'll try a bit.
Yeah, so, I'm happy to do it.
Okay.
All
so
right.
How many people do we have watching? Shall we start already, or do we
15 now?
Okay. On Meet, are we already doing the broadcast?
On Meet.
Sorry, on Zoom.
Oh, on Zoom, yeah. So I can click the broadcast button now, and then we'll be live.
Cool. Okay. Shall we start?
All right. Yeah. 3, 2, 1.
Oh, okay. So, hello everyone. Hello London Gophers. Welcome tonight for this second episode of our remote meetup. We're unstoppable, so COVID-19 is not blocking us, and we can still reach out to way more people than usual, hopefully. So tonight, well, this few months we're going to be sponsored by Tyke and GoBridge that kindly helped us with this Zoom account that allows us to stream and to reach out to everyone. And also JFrog is joining us as well as a sponsor, and we'll talk about them a bit later. There is a nice raffle that they organized to give some swag. A little bit about the agenda for tonight. We have Florian from JetBrains, who's gonna show us some Golang tips and tricks. We have Bruno, who will tell us about how releasing Go binaries the easy way. We have a little break. It's going to be like 10 minutes. Even remotely, we'll try to keep the break for people who need to take some, time off. And then we have Matt talking about defer. So without further ado, let's start with Florian. We'll hand over to him. We'll give him the control of the screen so he can tell us more about Golang tips and tricks. So Florian, over to you.
Hey everyone, thank you for having me today. Let me see if I can share the screen first, and let's see some Golang tips and tricks.
Cool. I'll stop sharing now so you can take over.
Perfect. Cool. So hopefully now you should be able to see my screen.
Yes.
Okay, perfect. So for those of you who don't know me, I'm Florian. I work for JetBrains as a developer advocate, and I usually talk about Golang and everything Go related. So Golang is our Go dedicated IDE based on the IntelliJ platform. And tonight I'm going to show you some tips and tricks. So no matter if you're just starting with the IDE or you're using it for a while or you're using any of our other products, you should be able to use them. There will be some Go specific tips and tricks as well. So stay tuned. And if you have any questions, please do ask them and I'll try to address them either at the end of the presentation, or I'll try to either send you tweets or reply to you by email, or we'll find a way to sort them out. Cool. So first of all, this is my ID. I'm running the latest 2020.1.2 release, and I don't really usually keep it like this, because even though you may see that I don't have any tabs or any other windows, I also prefer to focus on my code. So the first thing that I'm going to do is actually get into the Zen mode, as we call it. And this will allow me to actually focus on the code and so on. Cool. So once this is done, you'll see that I don't have the file view anymore. And one thing that I can actually do to bring it back would be to use the navigation bar, which allows me to quickly jump in the project wherever I need. And let's start with the completion tips and tricks. So as you can see, I've sorted these out by folders, by types, and so on. And at the end, I'll also share the presentation repository in case you want to try some of these on your own and follow the presentation along. So the first one would be something simple, but yeah, we start with something simple and then we continue to more complex ones. As you can see, completion works. It doesn't really need to import the FMT package or the log package or anything like that. And I don't even need to type the correct function name for that to work. So I'm going to have something like this, and bam, our first tip is completed. Let's go to something a bit more advanced here. So if I go to this function, and for example, I want to complete the handler here, well, I could just invoke the completion as normal, or I could call something that's called the smart type completion, which will narrow down the types that we see inside the function in this case. What I can choose now is specific types or symbols that match my underlying type. In this case, I can use directly not found, or I can create the lambda function for the handler. So let's create the lambda function, for example. And that's it. Another tip that we have for completion, if you are using it, would be having a postfix completion. And these are a bit similar to the regular completion, but what you can do with them is basically type a dot at the end of a symbol or an expression and get a list of other completion options. So normally you don't have anything, but the idea allows you to further use code templates to actually get some completion out of it. And in this particular case, I'm going to use the var postfix completion to define our variables. So for example, message, and it inferred correctly that this is an error, so I'm going to get error. With these, you can customize them, and you can also use your own postfix completions. And there's a different topic about that you can find on our blog. Further, there is a cool completion which is a bit hidden, but it can help you whenever you have a specific type that you want to complete using our completion engine. So you can press Control space once to get the postfix completion, but if you press Control space twice or Control space space, you'll get a list of all the functions and methods that allow you to have the first parameter the type of the variable that you're completing in this case. So the type would be string. And what I can do now, I can start just typing, for example, to title. And it's going to import automatically both the package and put the correct function name in place and so on. So this is useful if you want to discover functions which accept the first parameter, the type that you have under the cursor. Moving forward, we have something that is similar to postfix completions, but they are called live templates. And what you can do with these live templates is that you can define them. And I'm going to show you the IDE settings. And for live templates, for example, here in the Go section, you are able to see a few of them. We ship quite a few out of the box, but I also added some custom ones like the database data source. And this is because I never remember how to correctly type in this string to connect to a database. So in my case, if I just start typing dbds, just like a regular item that I would want to have completion for, I'll get both the description And when I press enter, I can then start customizing the parameters for this. So it would allow me to select the username, password, the host port, then whatever else I put it as a customization. It's not a live template per se, but in the spirit of completion, you can also use the if value different from nil. And in this case, I'm going to use the error because usually that's where we spend most of the time, right? Another thing that we can do with completion, and this is quite a new one, but I particularly like it, it's the fact that when you type a comma after the parameter return type, you will get automatically added the parentheses. So that should make things easier to refactor and add parameters if you do this manually. And if you're used to something like Go returns, you'll be able to see that we also offer completion for values on return. So for example, in this case, we can choose to return a type here, and we can say something like error, let's say new, and some error here. Cool. So moving forward, we have something that's called partial match completion, and I'm not really sure if you've noticed me doing it so far. So let's see what it's about. We can type, as the slide says, something like read, write, and then closer. And the IDE will automatically complete this for us and import the package. So we can just continue moving forward. So if you remember how the name is written, then you can actually go back and like quickly type it without having to type the full identifier name. Let's go with the completion items here. So for example, here, I don't have a need for printf. So what would I do? Usually I could say, well, print and then line. And because I did that, if I press enter, it would generate me an error, right? But what you can do is invoke completion, and then you can press tab, and it's going to replace the identifier to the right. And that's it. Like, we don't have to adjust for the broken code anymore. Let's move forward. Second to last item in the completion section. So as you can see, here we have an error. So I can quickly jump with the next highlighted error. And then here I can start invoking the completion to have completion for my interface added. And this allows us to do completion for items in the assertion cases like this for interfaces. And Golang automatically knows that, well, my typing actually implements the IO reader interface. And that means that I can safely assert it here. And our last item in the completion section. Let's say that we want to type function names, and that's fine, but we then switch back to parameter names and parameter types and so on. And that's usually a bit tricky to find a name, or to, like, you don't necessarily want to give it a name because you're not sure. Golang can infer the name of parameters based on the name of the type that you're writing. So if we say something like response writer, here Golang will see that, hey, this is an HTTP response writer, so you probably want to name this W because that's the convention. And then if I want to say I want to have a request here, Golang will again suggest HTTP request, and this time around will suggest R. And as you can see, for RPC request, it's going to suggest a different name. So let's see this in action here. If I say request here, I can add a second parameter, or I can add the request as well. And this is the last item in the completion section. Let's move to the next section, to editing tips. Let's say you want to select something quickly. Like normally you'd reach out for the mouse and be like, okay, I need to wait. I'm not really sure how to do this, how to do that, right? So I'm going to show that, and I'm going to show you how to use cyclic expand word as well, because maybe you don't really want to go here and start clicking and so on. So for selection, you can use the expand selection, right? And then copy, paste, and like that's not efficient. But if I know the identifier name above, I can go quickly here and I can say something like slash. Okay, alt slash and cyclic expand word, figure out that I need to use the word from above. Similarly, if I undo and I press the other shortcut for expand word but backward, I can cycle through words that I have defined below me. So this should allow me to quickly complete everything from the code below. Let's move forward. So parameters for functions, usually, especially if you don't necessarily know the package name and the function name and so on, are useful. And you can invoke them with parameter information. But this also works with structures. So whenever you define a variable of type structure, or where you initialize the structure, better said, you are able to see the parameter information, which in this case would be fields of the structure. And not only that, but for example, it works in substructures as well, or better said, embedded structures like in this example here. Moving forward with our editing tips, what we have here is the completion that works inside strings. So let's say, for example, you want to write a JSON. Now, the normal way to write JSON, or the standard way, would be you write this, and then you start writing this, and then you're like, okay, I need to escape this and that. So that's not gonna be really quick to do. You can use row strings as well. So like if I change this one here, well, now I don't need to escape, but it's still not really convenient. So what can I do here? Well, I can say inject language, and I can say JSON. So whenever I say that, you'll see a message that JSON was temporarily injected. And then you can say, okay, edit JSON fragment, and then you start typing in your like status and then 200. And you get JSON validation as well. So for example, in this case, I can see that there's an error here, and yeah, perhaps I should fix that. Okay, and then you can close this at the end whenever you're finished. This would be like a regular tab if you use tabs, but I personally don't. Completion works also in strings. For example, the long type that you see here, it's actually useful for Go template completion. So you can do something like this, and then you get completion for types inside a Go template, which could be helpful, for example, if you're writing anything that uses Go templates. Okay, let's move forward with our next tip. So let's say that we want to define a JSON, right? So first of all, well, I should create the structure here, right? And if you give me 1 minute, I will be able to invoke the create type here, and this will automatically infer that this is a structure. And then I can say, well, create the missing fields as well, and navigate to the undefined fields using next highlighted error. But then I probably need to add a JSON as well, because I'm marshalling this into a JSON. So I can turn this into the column selection mode, and I can just start typing JSON. And this is going to add the JSON tag for me. And then I can continue with whatever else I need to do in the structure tags. Cool. So almost ready with the editing tips as well. So I was mentioning earlier that you don't necessarily need to reach out for the mouse to select. You can select things with the extend selection. So this allows you to select semantically anything on your screen, and then you are able to also contract the selection. So in case, for example, you select something like this, you're like, okay, actually I need something a bit narrower, I can do that. And this works very well, for example, for fields and so on here. So, and speaking of selection, should probably want to use a selection to quickly select everything in a file or parts of it that match your identifier, for example, or anything that's really text. So I will say add selection for the next occurrence and select everything that's below the cursor. Or I can undo that. And there are shortcuts for skipping a selection or going above before the cursor. Okay, our other tip. So for example, let's say that you have completion, right? And well, you define a comment here and you can say, okay, add a comment, perfect. And then you want to refer something else like the demo type, right? So you can invoke completion here and that's it, it works. Right, so this is our completion. I'll skip the modules part for now because that's going to be a bit time consuming and I'll try to come back to it at the end. So if you're referring any file in your comments, you probably also want to quickly jump between them, right? Like I'm doing here. One way to do this is to actually make the selection and then invoke the navigate to file. And then there you can invoke the quick definition. And sorry, this is what happens when you change resolutions. You can preview the definition here of the file, so you don't really have to open it. But let's say we open the file, right? I don't have any tabs anymore, so what should I do? Because I also don't have a file view. Well, we can go back using the recent files, right? And this will show me a list of all the recent files I've been to, selecting the previous files as the last one. And I can press enter and that's it. I can also use the switcher to switch back to the file quickly. So this will allow me to jump between files quickly. Or I can use the recent edited locations to allow me to quickly have a preview of the locations my cursor was. So in this case, I can see that, yeah, I've been playing around in a lot of main Go files. And here, for example, I can select add to field, and everything that's add to field related will show up here. Cool. So let's go back and let's move on to the next navigation tip. Again, with navigating to our file, let's say that we want to navigate to this file and say, well, we want to invoke the structure, right? So if I press the structure, I can see quickly the file without having to perform any other operations in it. And I can see all the components in, better said, all the definitions in that file. But not only that, if I press the same shortcut again, I will then be able to see everything in that package. So in the package of the file that I'm looking at. And that is useful for a number of cases, especially when you're exploring a code base. Okay, so let's switch back. And the last thing that we can do is that we can invoke the select in, because, well, we probably want to actually see the where the file is. And we can either choose to view this in the project view, in the file structure, in our operating system file browser, or in the web browser. But in this case, I want to see it in the project view. And this is where I am right now. Cool. So moving forward, our last navigation tip here. So let's say you're reading the source code and you're like, okay, so where is my read function called here? If I press the correct shortcut for it, I can see the call hierarchy for it. And as you can see, it's pretty instant. And it allows you to locate all the instances of the read function calls. And this is where my type is currently invoked as well. And I defined it earlier. You've seen it in the demo. But what happens, for example, if I want to see the call hierarchy for the type hierarchy and so on? So let's say I want to switch back to this one, and I will say something like call hierarchy for the read function here. And then I will see that as well. So now I can browse and descend into all the functions that I called and so on. So that should be pretty useful as well. Moving on from the navigation tips to the refactoring tips. So if you're writing code and you probably are using interfaces as well, you reach out to a point where you're like, okay, I need to implement an interface. So what you can do here is you can say, I want to implement the methods of an interface. And I also want to create a type because I don't have any defined in the current file. And let's say I'm going to implement the read, write, closer interface because, well, I don't have imagination. And my type here. And now my interface is implemented. I can name the parameters for it and so on. And you can see that we are implementing the interface because I can navigate back to the interface. Now, cool. Moving forward with our refactoring tips. So let's say I want to change the signature of the add numbers. And well, maybe I'm in the call place, right? So I'm here, not on the definition place. And I can say, well, change signature, and then I can shuffle the parameters around. Or I can choose to add a error as a return type. I don't know why I would want that, but let's just say. Cool. So once this is done, maybe I also want to move this to a different package. So what can I do now is I can say invoke the same shortcut and say move, and then I'll use this file and this package, and I'm going to refactor. But the ID will prevent me because I cannot call a unexported identifier from a different package. So it's going to tell me that. Well, it will still allow me to do that if I really, really want to. But if I don't, I can go here, click on the exported and refactor, and it's going to be happy. So now it's going to complain, hey, like the name starts with the package name. Are you really sure? Yeah, I'm not really sure. I probably should name this a bit better, so I can just call it numbers. And if I don't press enter a couple of times, that would be awesome. So now I can go back, like add comments and so on. And I also can go back to my file and navigate to the usage place. And I can see that the ID also imported the correct path for my module and my file. Moving forward, and I know we are getting close to the end. So we have the ability to use interfaces, as I said earlier, but we can also extract an interface from a type. So in this case, I can invoke the same refactor this feature and say extract interface. And this will allow me to extract an interface based on the type that I have here. And let's say I want to extract it based on the this type. I want to call it demo, and then let's say main refactor, and that's it. So I can quickly create interfaces based on that. And our final tip from the refactoring, well, let's say that I have a string that string into a constant in this case, and I can choose to either replace only a single occurrence or all the occurrences of that string. And let's say I call it this message. But if I want to undo that, I can either hit the undo button, or if I'm a bit later on, I can say inline, and I'm going to inline that value. And that's it. From the refactoring, the last and the least, the run, debug, and test tips and tricks. So let's say here that we have a breakpoint, right? And I can choose to set the breakpoint with a Control F8. It's fine, but I can also choose to have conditions for this breakpoint. So I can say if error is not nil, then stop. Otherwise, continue and don't stop the application. And then when I actually choose to run the under the debugger, and we'll wait for the Gopher to compile. Oh my, so we have an error. It actually stopped when the error happened, and we didn't need to do anything special for it. So we only stopped when the execution actually matches the condition, which is great. Moving on. So from the here, like I don't have enough time to write the test, right? So let's try the refactoring. Well, there's nothing there. What can I do? Well, I can choose to generate, as we did previously for our interface, and I can say test for the file or test for the function and test for the package as well. And you can quickly write a test here, and you'd be able to say, oh, I want this, and I probably want to give it a name. I want the test name to be 1. I want, well, fields, let's say, I'm going to say message. And then what should I do? Let's say I have arguments and I have 1 here, and then I don't know. Let's say I want an integer and I want 1. And probably field 1 is not correct because if we see the error here, I can't really use that as a string. So let's change this a bit. So what do I do now? Well, I can run this using cover. And what will happen is that my test will now run. I will get the coverage profile for this. And when that happens, I can go back to the main file and I can see that, yes, I'm actually getting coverage for that. So if I go back to the test itself, here I can also say, well, toggle the auto test, which in my case it's enabled, and make sure that, for example, here we set the delay to 1 second because I want to do that. And let's validate that, the test is actually live and work. If you notice this, I have not saved throughout the whole presentation any file and everything just worked. Yes, my test will fail. So let's close this and let's make sure that, we don't have any coverage displayed. And that's it. Speaking of save, you should be able to see a save all if I ever press the save key, which I am not. Cool. So another thing here, let's say I'm running this in the debugger, right? So this is an application which looks like a server. Maybe it's your classic HTTP server, which does some things and so on. And it stopped because I put a breakpoint. Now, this is a feature that we introduced recently, and it allows you to tag Go routines so that you can use them. It relies on the runtime pprof support for labels. And what it does is it actually allows you to make a bit more meaningful Go routines in the debugger rather than just having to look at random Go routine names. So I can see that, for example, this one is stopped in the login point, even if it's in runtime park otherwise. Cool. So how did it look like without the tags? Well, I can go to the edit configurations. And if I would remove the debugger from here, I would be able to say debug again. And let's wait for the Gopher to compile. And this is how it would look like without naming Go routines. So if you want to debug and you're using Goland, you can actually go name your Go routines. There's a blog post about that you can read, and you'll be able to add labels to your debugging. Cool. Let's go. We have the last 2 of them here. So let's go here. I feel that this will make me jump to the test file. So perfect. Let's say you're writing benchmarks, which are important for your workflow and your application needs them. You can run benchmarks using our CPU profiler, memory profiler, blocking profiler, and so on. And by our, I mean the pprof profiler, of course. And this will display the results inside the IDE. It's going to use flame graphs. So if you're familiar with those, you can actually see your favorite flame graphs here. But if you don't particularly like them, as I don't, for example, you can still see the call tree, or you can see the method list and see, for example, what took the longest CPU time or what's the own CPU time and so on. Right, and the final one, I'm not going to show all the profiles from here. So let's say that we are debugging, and well, it's a debug tips and tricks. So it's a lot of debugging in place. And we got here to a place where we have a function chain call, right? Now, if I would press step in 2, I would step into make demo and then into greet, but I don't want that. So I can invoke the smart step in 2, and this would allow me to actually choose where I want to step. I can say, yes, I want to step into make demo, or I want to step into greet because I don't want to see anything related to make demo. And I'm going to do that. And another feature that I'm showing to you right now is the fact that whenever you have a simple enough debug string method that's returning a string, you can actually have some magic in the debugger, and it will show you a value that you're returning here. It has to be relatively simple because the IDE is actually evaluating that method. So we don't use the function called support from Delph. And it's going to display the value here. And I think that is it because I am running out of time. If there are a couple of questions, maybe we can take them. If not, that would be it.
Thanks, Florin. I think there are a few questions in the webinar chat if you want to take a look.
Sure. Let me see in the chat you say.
Yeah.
Okay. Give me 1 second. And sorry to make this so quick. I know we are in a bit of a limited time. There's going to be a webinar in the beginning of June where I'm going to go this at a bit of a slower pace. And if you want to attend, search on our blog and it's going to be fine. Let me quickly have a look here. So yes, so the repository for the tips and tricks, actually, let me say open on GitHub. And this one will bring the GitHub repository. I'm going to put this here while I'm reading the a couple of other questions. Okay. Okay, let me see. So chat. Okay. So does Golang integrate with Golang CA? We have a tool which allows you to run external tools. So Golang CA would be one of those that you can configure. It's called the file watchers. You will not get the same experience as you get for inspections. So for example, you will not be able to see any of the assistance and any of the messages inline and so on, but you can still use it if you want. The results will be shown in a separate window. You can configure that using the tools, external tools, and then you can say, file watchers. And then you can say plus, and then you're like, okay, I want Golang CA lint, which is predefined. If you don't have it, it's going to ask you to install it. And if you have it, it's going to show the configuration. And by default, we just disable one of these checks, but you can customize it and so on. I don't have it installed, so sorry, I can't really show it to you here. Okay. If you don't mind, I will address some of the others in private. So I'm going to yield my time to the others speaking tonight. So thank you once again for having me here tonight. Thanks for watching. I know there's a lot of them, but like I said, join us on our webinar that we'll host in June, and it's going to be at a bit of a slower pace.
Thank you very much, Florin. That was really interesting. I'm going to now start presenting back again. Let me give me a second. So share screen. Okay, hopefully now everyone can see the slides. Cool. So let me just move on. Okay, so next one is the usual slide with all the our pointers. You can find us on London Gophers, where probably you've seen that we're live streaming. Like you saw the link for live stream to follow us. Then you can find us, of course, on Meetup, which is where where most of you registered from. You can find us active on Slack in the London channel. There are other channels that we are usually active on, and one of those is going to be mentioned later. And of course on YouTube, most of you are probably watching us right now on YouTube, so that's where you can also see the current live stream and all the old videos, and everything will be recorded and left there. Just, keep your distance, but follow us, safely. Then the next one is about this. I mentioned another channel, which is the London Study Group, still on the Gopher Slack. And this channel is where the study group gathers and discuss about what they're doing. And I think Beth can then update on what happens there soon. I see there is a workshop nearly ready. So maybe she's gonna, I don't know, Beth, do you want to jump in and say something now, or is there anything to add?
No, we have a workshop that's coming soon, but it's not, we haven't actually released it yet, but all the code's done. So it's kind of like a workshop that has a few kind of goals to work through. So it should be a bunch of fun. And it's good to get people working together and also to write some code. So yeah, all good.
Sounds great. Thank you. So again, great hearing that the community grows in many different areas, and workshop is another one that is really useful. As if you found the Florian talk interesting and you're curious to try out some JetBrains products, you can join our raffle. Again, you go to that link. It will ask you for a code, which is online. And then you will enter this raffle. We have 3 free JetBrains licenses to give away tonight, as every month. As I mentioned at the very beginning, JFrog is also happy to sponsor us, and they are offering some swag. These slides will be public as well. So if you want to take a note now of that link, or if you are so quick that you can take a picture of that QR code, otherwise we're gonna make these slides publicly available, so you can take a look at this later. And now I'll hand over to Bruno, who's gonna tell us about releasing Go binaries the easy way. So let me just stop sharing this, and Bruno, over to you.
Okay, let me just share the screen. Okay, hope that everyone can see it. So my name is Bruno, as Antonio already mentioned. I am a software engineer in Utility Warehouse, and today we'll be talking a bit about how to release Go binaries the easy way. So the first thing that we have to do is create something. So we have to make an application. So the easiest way to do it is create a hello world, but let's do a different one. So let's say hello London Gophers, of course with emojis. And once you have this, you save this in probably a main.go file, and you want to build it because you need to run it somewhere, right? So to do this, you can call go build main.go. With this, you create a binary which you'll be able to run in probably your machine. So if you use a Mac OS, you'll be able to use in Mac OS. You'll not be able to run in Linux. But if you're running a company, most likely you'll be running something on a Linux server. So how do you do? Usually you just use GOS Linux and put the architecture. It's fine. But we are going beyond that. So let's say that we want to create a CLI. So if we want to create a CLI, we want more operational systems, architectures, and easily you end up with something like this, a make file with many, many calls to this Go build. But it will work. It will work. It's a bit of a trouble, but it'll work. Once you have all the binaries, you need to release. I will use GitHub here because it's the tool that I use, but you can use GitLab, Bitbucket if it's not down, but you can use many of these tools. So in GitHub, you have this release page where you tag some version, push your tag. Then you can include, of course, a description, which will be usually your changelog. Like some people don't include anything, but it's really helpful for the users. And finally, all those binaries, you need to attach them manually on the attached binaries there. And then you publish the release. Done. Easy, right? It's really easy for 1 or 2 versions, but if you keep doing this, if you keep repeating, it kind of seems too much work to just release some binaries. So as I'm a developer and I'm lazy by nature. That's why I automate things for my job. I automate things for me and for other people. And I was like, there's probably a way to do this. And there is this tool called Go Releaser. And Go Releasers allow, I would say that they have three main pillars for me. One of them, they simplify the releases. So with one file, you do build and release. So you don't need to do make files for one thing and then go manually do other things. Second, it allows you to deploy in multiple channels. What I mean multiple channels is you can deploy in GitHub as is shown. You can deploy in Docker. So for example, if you have something that will go to Kubernetes, for example, it will deploy there as well. And you can deploy in Brew, for example, Brew, Snap, and even for Windows. So it depends a lot on your configs. And finally, it's really, really easy to integrate with CI. So if you circle CI, GitHub Actions, they have many examples, and it's literally really easy to integrate. So first of all, of course, we'll need to install it. So depending on the operational system, there are different ways, but once installed in the directory that you are, you just call go releaser init. With this, it will create this YAML file. And I personally don't like YAML files, but in this case, it's fine. It's not that big. It's not like a Kubernetes manifest that's kind of can get really big. So once you have your YAML file, you get into YAML file, and I will go through the basics here. It's not going to be like, if you want with more details, of course, the documentation is super rich. So the first thing, and it's required, is defining your project name. Here I'll just call in cool project. Then this build section, you just point to where your main file is. So in this case, cmd main go. And of course, you need to specify which operational systems and architectures. Here you can see, I just using a really wide option. So from Linux to Windows, from 32 bits to 64 and even ARM. So this would run basically everywhere. So here you can even specify more things. You can specify, for example, environment variables to disable Seagull or enable it. You can put meta tags, so the LD flags and other things. So having that, you have the build process. It will just create the binaries for you. But you remember when I mentioned like you should create a changelog. Some people would say, it's too hard, too much work. And you can create like a changelog based on your commits. You just filter some of your commits and then boom, you have a changelog. It's that easy, it comes out of box. And this one, okay, so this one, archives, it's by default, Go Releaser will give you a tar. And we know Windows users, they use zips usually, or rars. And rars is a really funny word in English, by the way. And if you want to release in a zip file, you need to put a format override to format to zip. And not only that, if your project is open source, most likely you want to include extra files, such as license or a manual. So to do this, you can specify the files that you want to include besides your binary, of course. But if you want to be an anarchist, you can actually just wipe this whole thing and just use format binary. It will just give straight away the binary. You don't have to care about the license or README or anything. You just rely on them checking GitHub or whatever you're deploying this. And for me, one of the most cool things is it deploys to Docker. I use Docker Hub. So at work, we use Kubernetes. For personal projects, I use Docker Compose. And it's really cool when you have some small server that you create some code there, and then you can straight away get from a Docker repository. And it allows you to create different templates. So here, for example, you have the first one. It's a tag. So you usually be using Senver. So you have v1.1.1, and there you go. You just have this tag. But then is a patch, right? So it will increment the minor version as well automatically for you. And probably is in master, so it will bump the latest version. So everyone that's just getting the bleeding edge, they will get from the latest. And in this case, I usually use a Docker file, a local one and a production one to different instructions. So you can specify a different Docker file depending on your needs. And if you want, for example, to have an Alpine and an Ubuntu image, you can create an extra, because this is an array at the end. So you can create an extra image template just for that. And finally, from the configs bits, one thing that for me was really magical, it's the brew. So I use Mac for a while now, and I was always amazed, like, look, I can do brew install some tool. And I always thought it was quite complex to do this. And with Go Releaser, it's so simple. You just need to create a repository called homebrew-tab or whatever, like I specify here at the name, as you can see. And you create a folder called formulas. So once Go Releaser pushes and deploys something and release something, it will push a formula for the specific project inside of this repository. So people can just do brew install your tool. It's amazing. It's really easy. I was like, I thought there would be some caveat. There is none. And of course, there are some configs for Windows as well, even for Linux to create the RPM and dev packages. So yeah, it's it. Like the config file will be probably not that big, probably be copy and pasting some stuff from the docs. And once you are happy with it, you have some features, what do? You tag the version. So again, I'm using Semver here. By the way, there was a really interesting talk some time ago in Gophers London. So if you don't know what is Semver, have a look on this talk. And you can just you just tag it. You need to get a GitHub token because part of it is creating a release in GitHub. So to create this, you need API access. But it's really easy to get this on the developer dashboard. And finally, you call Go Releaser. If you're first time, I would recommend to use skip publish and snapshot because it will not actually push any release or anything. It will just give your binaries. It will give the image. So you can test some stuff locally, at least for the first run. Once it's done, it's done. You just run Go Releaser and it will use it automatically. And you know if it doesn't work because or it's going to explode or it's going to make your machine super slow because remember, it will be running multiple Go builds at the same time. But okay, with this, you have like a release page, a beautiful release page. As you can see, it generates the changelog, the Docker images, probably in Docker Hub as well. And depending on, of course, your provider and the archives, the assets with the binaries. But I'm still lazy. I don't want to have to remember to install tooling and ask people around to install tools. So how do I integrate with CI tools? For those who don't know, CI tools are like basically continuous integration tools. It will allow me, for example, to run build, test, linting, and then finally, if everything passed, release somewhere. To do this, I'm going to use Circle CI here. It's the one that I am familiarized, but GitHub, it will work with GitHub Actions, GitLab CI, and so on. So I'm going to go quite quickly because it's quite vendor specific, this one. But you have a workflow I'm defining here, as you guys can see. I'm basically ignoring any branch because I don't care about, for example, some release branch somewhere or some feature branch. And I'm only caring for tags, specific Semver tags. So once you have one of these tags, it will run the release job. And the job itself, it's really easy. I guess I copied it, I can't remember, but I copied from the docs. The only difference is if you're deploying to Docker, you need to add Docker login here. So you need to set environment variable with your username, password, and if a specific repository, add this repository as well. Finally, you just download Go Releaser, run it, that's it. Once you have this file somewhere, and don't forget about the GitHub token, it needs to be set on as environment variable as well. Once it's set, you tag the version, basically creates a message, push it, and once it pushes, it triggers Circle CI automatically. It builds and release your project straight away out of box. So it's really useful when you have an open source project and a team, because then everyone kind of relies that Circle CI being the source of truth of all your deployments. Finally, if you want to have some examples, I have 2 projects that I have in my GitHub. So have a look in PWA server and Mermaid server. Like they have the Circle CI integration and the Go Releaser YAML. And yeah, that's it. I hope that you guys like learn something and can perhaps make your release or well build and release process easier. My Twitter, Slack, and GitHub handle is @brunolees. And if you want to contact through email, there's contact@brunolees.net. By the way, if you're searching for any position, we Utility Warehouse, we have open positions. So I will be glad to answer questions about the talk, or even if you're searching for some job. That's it. I guess I have some time for QA. Thank you very much, guys.
Thank you, Bruno. That was really, really cool. I think I used this tool a while ago, like quite a long time ago, and I didn't realize how many functionalities they've added. It looks really, really cool. So there are a couple of questions I can see on the chat. Do you want to read them, or do you want for me to read those?
Let me have a look if there are like,
One says, okay, love Go releaser. Question: any way to release multi-architecture Docker images?
So I suppose that so multi-architecture, right? You can define. When you say multi-architecture, I'm not sure what you exactly mean. You can have different Docker files. So I suppose that you can release different configurations. I just don't know what this would be exactly on the multi-architecture. I know that you can have multiple. I just showed one, but you can add multiples.
Cool. Okay, there is another question I think just arrived, like very similar. So maybe if someone has more questions on the multi-architecture, they can reach out to you directly and ask more.
Yeah.
One is also, does this work with GitLab CI like it does with GitHub Actions?
It's curious because it seems that he's comparing something with GitHub. I haven't tried with GitHub Actions. As I mentioned, I usually use Circle CI because it's my go-to for a long time. But I guess that it should work fine because in their examples in the documentation they have like for GitLab, the GitHub, and Circle CI. The only trick might be that you need to set up a different token because for GitLab you have it's not GitHub token, of course. That's the only trick. The rest should be the same because you just download the binary and run against your Go releaser file, and that's it. There's no extra trick on it.
Cool. Okay, thank you very much. I don't see any more questions, but again, if anyone is curious, and they can reach out to you and ask for more. Okay, so next slide is the usual conundrum. So I will hand over to Kat, who's going to read this, and then we're gonna have a quick break for like 10 minutes, and then we come back for the conundrum solution. So Kat, over to you.
Hi, everyone. So the conundrum today is our own custom version of the printfm or printf function with some tweaks that we've included. So the first question is, what will this code print? And the second question is, will this particular for loop compile and work, or is there anything that we need to change in there? So if you have any ideas for explanations, post them in the, well, feel free to discuss it in the YouTube chat, and then we'll somehow crowdsource the answers when we come back from the break. So should we leave this up for the break, Antonio?
Yeah, sounds good. I'll leave it
yeah.
up, and then I guess we can come back in 10 minutes. So 8:08. Sounds good.
Cool. Yeah, see everyone at 8:10.
Cool.
Okay, welcome after the break, everyone. I'll give everyone just a few seconds to go back to the TV or screen. So if people have any suggestions, or if you just want to post your guesses in the YouTube chat, I'm also watching that. So I think that's the easiest way to crowdsource the answers. Oh, I'm just rewinding back to see where the discussion started. All right, so maybe does anybody want to share their guesses for what will the code will print on the YouTube chat, or in the Zoom chat if you're on Zoom?
I've seen this already, so I would cheat suggesting any solution. So I'm just not going to do that.
Yeah, cool. We can do that. I was just catching up on the YouTube guessing. Thanks, Matt. I'm curious, Matt, if you want to unmute yourself and maybe explain why you think the 0 is a hello.
Hello, because it's the first argument in the slice that's passed in.
Yep. And do you so you reckon that the only things printed will be 0, hello, and 1, the number?
Well, I think that you'll get a weird string first, because if it's trying to print that format with the A, that A is a slice of interfaces. So it's going to maybe turn that into a string and put it in the S, and then the D will be missing.
Yeah.
I don't know. It's
All
really
right,
hard to do. It's much easier when the computer does that, isn't it?
Yeah, well, easiest thing is just to check it in the Google Playground and see. Not Google Go Playground. All right, let's go. Go to the next one. So this is just our placeholder slide. This is the same thing. There's a bit of a lag between everything, so just bear with me. Right, we've built the suspens. I'll just let the live stream catch up. So actually, this was a bit of a cheeky question. I slightly trolled everyone. So what will this code print literally is it will print a go vet warning if you have vet running. It will tell you, it will work, it will run, and it will output the hello, whatever number of Go friends, and then what you said, Matt, the 0 and 1. So basically, you'll print out the array with the indexes, or the slice with the indexes. But it will also warn you that A should be written as the variadic parameter. So that
it wouldn't print that as a slice in some way. Then it will actually turn it into strings.
It will, yeah, it will. It will. That's kind of the thing that surprised me when I was writing this, is that it kind of just copes with you missing the variadic argument. It will just assume it's a string either way. But then the further interesting part is if we go to the next slide, just bear with me while this changes, is that the for loop also will work without the variadic argument, because the Go compiler actually converts the variadic parameters to slices by default. So this is correct, and you won't get a Go vet warning. So A in this case is just going to be treated as a slice rather than the variadic parameter. So I found it really interesting that in one place it's kind of defaulted to a string, and then in another place it's being treated like a slice. So there you go, little quirks. But I also thought that this for loop If you're using variadic arguments and you kind of ever catch yourself thinking, can I use this in the for loop easily? Then the answer is yes, because it would just be treated as a slice. So there you go. That's the conundrum.
Cool. Okay, I think from just to like a small correction, I think that what Matt was mentioning, because when you run it, you will see the go vet message, and it will compile and will run, but it will not run correctly as showing the entire content, but it will still show you the address and like that weird like interface addresses and all that stuff. So it's not, it kind of works, but it's not as expected. And you still need, in the first part, you still need the explicit conversion to variadic argument, while, as you said, like the second part is just, you know, doing it automatically, because when you pass that into the function, that A becomes just a slice. But I think the first part that was quite weird is that, yeah, it's still, it prints something, it still compiles, it gives you like a bad warning, but at the same time, what it prints is probably not what the user would expect. But anyway, well, feel free to try and take a look and see what the result is. We can go on now. So again, a little reminder on our JetBrains raffle. Go to gophers.london/raffle. I will ask you for a code you can put online, and that enters you to our raffle on Twitter, and we will reach out to you if you are one of the 3 lucky winners. Again, swag from JFrog. You can catch up on this QR code later. This will be public. And I don't want to defer this any further, so I think I'm gonna hand over to Matt, who's gonna tell us more about defer. So over to you, Matt.
Okay, hello. Thank you very much. Thanks for having me. Can you see my telly?
I think not yet. Oh, you can cut? Okay.
You can see it, yeah?
So I could see it a second ago, and then it disappeared.
Oh. I'm going to share desktop 1, I guess, and then...
Now, yes, I can see more. Yeah.
Yeah.
Okay. So you can see my slides, yeah?
Yes,
yep.
Perfect.
Okay, cool. Yeah, so I'm going to talk today about defer. And defer is my favorite feature in Go. I remember when I first saw this little keyword, I was kind of blown away by it, really, and by the power of it, and also by the simplicity of it. And I couldn't really believe that I'd got so far without having something like that in the language before. So in this, well, I'll tell you a bit about me. That's a picture of me there, so that don't remember what I look like now. Remember that, because now I look shipwrecked, but that's how I'm meant to look. So I working at Pace, and we're building a minimalist project management tool completely in Go on the back end, and then we've got a Svelte front end. And we use defer a lot. I'll show you the evidence of that. We also did on Go Time, we did an episode on defer, and I do recommend this because we talked to the person who did the recent optimizations of defer, which I'm going to also show off today. And then please tweet me. I like answering Go questions on Twitter. So please, and don't DM, ideally, do it publicly, and then other people can also join in. So yes, I did a search. We've been building Pace for about 6 months, and we've used defer 418 times in that period. And that's an average of 69 defers a month. So we definitely like our defers at Pace. So I'm going to tell you what defer is and how we can use it to make our code better. But we'll also look at some of the common gotchas and what's going on really under the hood, which helps us make decisions about where and when to use it. And then I'll show you some of the performance optimizations that have been going on over time. And they do this sort of in the background, and we just get to benefit from these optimizations. So it's a really cool, I think it's a great thing that we don't have to worry too much about that kind of thing. We can just be users of it. And I'm going to answer, should I be using defer? And, you know, it's obvious that I'm going to say yes, isn't it? There's no suspense built there. So what is defer then? Well, deferred functions are invoked immediately before the surrounding function returns. And they do that in the reverse order. So it's quite a simple idea. Essentially, you defer a function, and then when the function you deferred it in exits, that deferred function is going to be called. So code like this is quite obvious if we call the goodbye method and then we call the hello function, then it's going to print goodbye and then hello, because that's what we expect. That's the order we did it. If, however, we deferred that goodbye call, then the order will flip around, and that's because the goodbye call is being run when the main function exits, not before. So remember the thing about the reverse order. What would you expect this to then print? You'd be forgiven for thinking this is going to print 1, 2, 3. But actually, yes, they run in the reverse order in which you call them. So that's called LIFO, which is, you know, last in, first out. And it's really, that's it. At its core, that's as simple as defer can be. But there's some interesting cases when we start to dig in and have a look at how we can actually use defer. One of the best use cases is when you're closing files. So in this code, I'm opening a file, and then if there's no error, I'm going to go and open a second file. And then I'm going to process this text from these two files and then close the files after. And if you think about it, that's the order in which we want things to happen. You know, it's completely reasonable to write code like that. But watch out, as these very long arrows will point to, there are a couple of places where we could leak file handles, or we could not close files. And it is important to close files because it's a resource that the system gives you. You need to respect that and be a good citizen on this computer and give back, you know, free up those resources. So in number 1 there, if that second file fails to open, we're just going to return the error. What we've done then is left that first file open. And in the second case, if something goes wrong processing the text, we'll actually leave both of those files open when we return that error. So that's not really brilliant. One solution would be to close the file before we exit at each point. So we could, you know, in the first case, we can make sure we close that first file, and then if process text fails, we're going to close both. But imagine if you've got 7 or 8 files or things that you're doing that need closing or need cleaning up. That's going to quickly get a little bit out of hand. And this really is the perfect use case for defer. So what we do instead is we open this file, and as long as it opens successfully, there's no error, we then immediately defer the close of that file. We do the same thing for the second file. And now, at any point that this function exits, we know that those files are going to be closed. And so that's really the power and the sort of simplicity. Look how easier that is to read than where we have to go and close at every exit point. Michael McLaughlin from Uber points out that this actually can encourage us to ignore the errors that come back from these close calls. And that is true, particularly if you're writing a file, because when you close the write of a file, it actually will do some final work to close the file, which could fail. So it's important to check errors of when closing writers, for example. And there are other cases. This close method is actually an interface in the standard library called IO closer, and it returns an error, which I regret. I wish it didn't return an error, and you'd handle the errors in a different way, which you can do. In fact, in the writing a file case, there's a sync method which will do the final bits and pieces, and you can check the error of that. So I prefer that kind of thing. I wish that we could just always call close in this way. Another time it's very useful to use defer is when you're making an HTTP request. if you make an HTTP request, you get the body of that, and you are responsible for closing that body. It's quite easy to forget this, so it is something you have to remember. And defer is the perfect way to do it, because again, if we have other code going on and we could exit in different ways in different places, we want to make sure that we still clean up after ourselves and don't leak things. And if you think about it, most of the time the code works without error. So it's quite possible you would never, in your test code or when you're testing it yourself, you'd never actually notice these files being leaked. So this is where defer really helps. We use defer when we're working with locks for the same reason. So here I've modeled what can only be described as a kitchen. And this is we want this kitchen to be a thread safe kitchen so that it can receive many orders at the same time, and we're not going to have any corruption with the internal state. So in order to achieve that, we really need to use mutex to protect that internal state here. So when we call take order, we're gonna lock the mutex. We then go and do all the bits and pieces, and notice there are other errors that could happen down here. And then at the end, we're gonna unlock it. But the problem is, as these extremely long arrows point to, there are places where things could go wrong. Like if the order's not valid there in that first case, we're gonna return the error. We've locked the entire kitchen still. We didn't unlock it. So that's like, that's not a great kitchen, is it? That's a very temperamental kitchen if it's behaving like that, frankly. So the solution is to use defer to do the unlock. And notice how useful it is to have these two things right next to each other. When you get used to that pattern, you'll easily see where you've missed an unlock call. And it's nice that the things dealing with locking and unlocking are in one place in the code. It just cuts down on the cognitive load needed to kind of debug this later. Jana Dogan makes a good point about that, which is if your attention is easily grabbed elsewhere, it's very easy to forget these simple things. And so having a way in the language to address it up front is very powerful. So defers work with conditions too, and this will give you a clue that there is some something in the runtime going on in order to make defers work. So here I've added a secret option, so you can make a secret order. I don't know why that would be a thing, but in this kitchen it is. And so what happens is only if it's secret will it lock the kitchen and increase the little counter here. And so the defer is happening inside that conditional block. And that means it won't be called if the code path didn't take that route. So then we know something's happening at runtime, isn't it? And we'll find out what that is. We can use defer to clean things up, and doing this in test code is extremely useful in particular. So in this example, at number 1, I've got this little cleanup function, and it's just a simple function there, really. It's there for documentation, really. You could do this anonymously without creating a type. But what we do is we have this create test files function, which is going to return as the second argument the cleanup function. And what we expect is we can create this little cleanup function inside the actual function that creates the test files. So in one place, we're creating the test files and then creating the function that's going to clean up those test files. We just return that, and when we come to use it, we get quite a nice little API where we ask for the test files, we get them, we immediately defer the cleanup, and we know that however this test exits, we aren't going to be leaving files left around. Even if tests fail, they'll be called. So it's very powerful. And apart from maybe the weirdness of creating the little function inside another function, what a lovely API you end up with for your users. You can do this as well in real code, not just in test code. This actually is entirely the code needed to build a little timer. And how it works is, again, we've got this stop function. You could just have the function, but it's nice for documentation, I think. And then we have this new timer function, which is going to return the stop function. And we're going to catch the real time in here and store that as start. And then we create an anonymous function here and assign it to the stop variable, which we return. And because of the closure environment, it has access to the start variable. So at 3, it can do something like time since start. And this is just going to print out how long it took essentially between calling new timer and then calling the stop function. And so in some middleware for HTTP service, for example, you could use it like this. You get the stop, you start the timer, immediately defer the stop, and then you go about your business. And what will happen is it'll print the amount of time that took. So that's relatively simple, nice little pattern you get to reuse. And of course, it doesn't just have to print things. That could be, sending it to some other system where you might be tracking these kinds of things, some monitoring system. You can use this technique in a variety of ways. There is a thing I've seen which I really don't think we should do, and I call it squashing defers. So this number 1 is technically correct, but what's happening there? It looks almost like we're deferring the setup, but we're not. What's happening is that setup function is called immediately. It's returning the teardown, and then that's the function we're deferring. But it's just too weird. And I understand we have this kind of temptation to really shrink code down. For some reason, it feels like we've optimized or something. But what we've done is just made it a bit more confusing than it needs to be. This other option, I think, is much simpler. Look, we'll store the teardown and just defer teardown. You're actually saying teardown as well. So it's more storytelling that you get to do for yourself in the future and for your teammates and open source colleagues. It's time for the defer fact of the day. Sorry, that sounded like Alan Partridge, didn't it? Ken Thompson came up with the idea of defer and is probably influenced by the Plan 9 kernel error handling stack, which you can check out there. Thanks to Russ Cox for providing these. Some of these are unknown facts about defer, so it's a very exciting time for everyone. Just gonna have a sip of this water, excuse me. So it so far looks like defer, it's just all roses. It's not all roses. There are some common gotchas. And have you seen this optical illusion before? This is amazing. The A and B squares, the background color on those squares are the same color. And this is a common gotcha. Something's going wrong in the software in our brain. It's trying to rationalize that shadow and it gets it wrong. I promise the A and B are the same color. I checked it with the digital color meter. They're all, that's 5C, 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 both of them. If you don't believe me, please check that for yourself. I think you should be critical, but imagine if that wasn't true, why would it even be in this presentation? Do you know what I mean? So think, okay? It's definitely true. Right, so let's have a look at a common gotcha then. Most of the common gotchas around defer relate to some flavor of this issue, which we'll talk about. What do we expect this code to print? You might say, well, we remember that they're going to be called in reverse order. So you might think, yeah, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. What's wrong with that? Well, actually, that would be wrong. In fact, it prints 10, 10, 10, 10, 10, 10, 10, 10, 10, 10, which is not what we would expect. And what's going on is this item variable is getting reused when it ranges over. And since the defers all happen once this function's exited, by that time, the item has been set to 10. And so then they all are pointing essentially to the same thing. They all then print 10. The solution is to actually have a little anonymous function. So in this case, I've just called it handle. And we take the item as an argument, and then that creates a different closure environment in which the data can be stored. And so we can then pass that item as a variable, as an argument, sorry, into the little function. So I think that's actually quite easy, quite a lot easier to read as well. I think it has that benefit. You can do this inline as well here at number 3, and just wrap it in a little anonymous function and pass the argument in immediately. I find that to be a little bit more weird, but if it's a small little case, then fine. Usually they're not small cases, they grow. So I prefer the little handler one. If you like defer gotchas, and that could be a thing, people could like defer gotchas. There is a great series that goes into lots of these by Inak Gumas. So check these out. You can just Google that. You don't have to type in that entire URL, but maybe you do. You might be into that. I mean, if you like defer gotchas, maybe you probably would also be into typing in URLs by hand. Okay. So how does defer actually work? It's really cool. I went poking around. Remember, Go is open source and Go is written in Go. So we can go and see how it works. And I found this type. This is the little defer structure that gets created every time you defer something. And there's some magic in there. This is some of the standard library, especially the low level stuff, looks a lot like C. And I wouldn't have written the code that looks like this, but partly that's because I don't really understand the domain as much as the people who write this do. So for example, FD, these variable names, PC, SP, they probably mean something in that domain if you understand it. But if I was writing this, I'd use names that were very explicit because this looks hard. I want to draw your attention to one of the fields here. It's quite interesting, is this one called link. And notice it's a pointer to the same defer type. And that really shows us that defers are in fact a linked list. What happens is when you call defer, the first one's created and the function points to that. And when you then call another one, it's that defer, the new defer points to the old one. And so you end up with a kind of chain of defers in that way, which is a very efficient way of doing it. So let's have a look at that visually then. I'm going to call defer 1. So the function is, when it exits, it's going to call 1. Then I defer 2, and the function then points to that 2 defer, and it's the 2 that via the link defer type thing points to the 1. So you see, you get this chain. When you then defer 3, of course, the program's pointing to 3, and that one is linking down through the chain. And this is how you get, it's a very efficient way of creating essentially that chain of defers, and also explains in some way why they run in reverse order. It's time for another defer fact of the day. Defer was originally called catch, both chosen by Ken Thompson, and they also considered undo and on return. So just imagine what your code would be. I mean, I think undo is a particularly kind of strange one, but it's cool. Okay, so have you heard of the defer performance problem? Some people I've heard, particularly in the past, less so now, but I have heard people say we don't use defer because we want it to perform well. Well, probably it doesn't matter in your case, but maybe it does. And in low latency systems or in code that's really being run, lots and lots of times, nanoseconds do add up. So let's have a look. This is the approximate cost of defers over time. In Go 1.7, you're talking 99 nanoseconds. It's still not insane. It's not too slow, but check out the progress that's been made until we get to Go 1.13, where we're down to 35 nanoseconds for a defer to happen. Now, bear in mind, a normal natural function call is about 3 nanoseconds. So, yeah, fine. This is why people said, therefore, don't use it. But in practice, that isn't really something you should necessarily worry about. But don't worry, though. What we're going to do now is see if we can optimize defer. So I've got this little function here that's going to get some bread. Lots of people into bread these days. You can see I get some dough. I defer putting the dough back. I get some seeds. I defer putting the seeds back. And then I add the seeds to the dough and I bake it, and then I return the bread. And that's essentially how you make bread, I think. So could we undefer this in some automatic way? If we had some process that ran before we built the code, could we do something here to kind of avoid the defers at all? And we could get the compiler to open code it. That trick that I talked about at the beginning, where you just can call the functions directly, just open code them. We could get the compiler to do that for us. And actually, in some cases, it will do that. But what about conditionals? Remember the runtime element of defer. And this is an example that demonstrates that. If we add this with seeds bool as an optional argument, then I'm going to check if that with seeds is true, then we're going to get the seeds and defer putting the seeds back. That means I'm not always going to put the seeds back. So we can't just open code it, everything. We have to be a bit smarter than that. It leaves the question here when we put the seeds back, we don't know if we should or not. We'd have to go and maybe copy or do some more work. And I actually built a little prototype of this a few years ago, thinking I was clever, that I could solve the deferred performance problems. And then as soon as there was a conditional, I was just like, okay, it's too hard, I'm not doing it. I was probably busy as well, but probably not. So in Go 1.14, though, Dan Scales and the team have added open-coded defers. So where a defer is called 0 or once, so we're talking if conditions, we're not talking about loops. Loops are more complicated. The compiler actually will assign a bit for each of those defers in a variable, very satisfyingly named defer bits. And it uses bit manipulation to switch on and off bits. Okay, so if you're not familiar with that, it's worth kind of understanding. We tend not to use it too much, but the compiler and the runtime, the Go runtime, it matters. Performance does matter, and they do care about it. So they use bit shifting and things, bit manipulation. The defer statement, it just sets the bit essentially, and then it saves all the closure information in that defer type. So in the condition with seeds, it'll just set a little bit to say, this, whatever the code is, that defer function was hit. So I'm going to set the bit, we should call it. And then at every exit point, the compiler open codes, which is that process, it open codes each of those deferred calls and calls them only if that bit is set. So it is really a bit like capturing the with seeds bool and checking that at each exit point. That is literally what it's doing. So for example, if we're deferring this F1 function and then we have if with seeds, we then are going to defer the second function only in that condition, it turns into something like this, where we check we have the defer bits, we set the bit for this particular defer, and then when we at each of our exit points, we then check to see if that bit is set. And if it is, then we call it. And if it's not, we don't call it. And this gets copied to each of the exit points. However, if this will only work for a specific number of defers, and I found the code that gives us a clue to how many defers this optimization works for. By the way, if it doesn't, if you go over this and it doesn't fit this case, it just falls back to the previous defer 35 nanosecond one. So it'll always still work, but in order for you to get this optimization, there's a maximum number of defers you should use in a function. This is the code that tells it. I mean, this code looks like it was written by when a cat walks across your keyboard, but it's not. And if I zoom in a little, we can see there's a clue here. And the clue is in this uint8 type. Uint8 is an unsigned integer of 8 bits. If it was an int8, one of the bits would be used for the sign, which is to tell you whether it's a positive number or a negative number. But because it's an unsigned integer, it doesn't have the sign bit. And so we have 8 bits to play with. So that means we can have 8 conditionals. And so up to 8 defers, it will work. So there's 8 bits in that type. That gives us 8 defers per function. So if you're lucky enough to only have 8 defers in your function, let's see what performance we get out of this. So remember, Go 113, 35 nanoseconds, approximately the cost. Calling functions naturally is 3 nanoseconds. With this optimization, with less than 8 defers, it's down to 4 nanoseconds. So this does away with and finally puts to rest any talk of avoiding defer for performance reasons. And we'll have a look at the final defer fact of the day. Some of the defer design discussion happened on Google Wave, which doesn't exist anymore. And so actually, there's a lot of this discussion is now unfortunately lost. So it's a very sad fact, that one, very sad fact of the day. So should we use defer? Yes, you should use defer. Go and use defer now, please, because they're fast and they make code easier to read. So use defer, especially since Go 114. Thank you very much. Cheers, mate.
Thank you, Matt. That was really great. I don't know if we have maybe some time for a couple of questions. Let's see if there is anything on the chat quickly. Who designed your slides?
I did it myself.
Then okay, there is okay. This says, can you see that? So do you think it is a problem that it encourages locking a mutex for the scope of a function? It is in when it, it's easier if you read that probably.
Yeah, okay. So they're saying that if you lock and then unlock, you're locking for that entire function. And if you want to be more optimum, you can just lock around the actual bits of data that you're dealing with. So I'd err on the side of readability naturally. But yeah, I mean, if it mattered that you're getting contention because you're locking for too long, then yeah, I've seen it lots of times when you go and tighten that defer up. That's a fair point. Should probably mention that next time.
Cool. I think there are no other questions, but thank you again.
That's good because that presentation contained basically everything I know about defer. So there's no question that I'm really pleased there's no questions.
Cool. Okay, so here we are back at the next slide. So this is just to wrap this up. Next meetup is gonna be, we assume it's gonna be still online, so similar format, Zoom and YouTube, and it's on the 17th of June. So we're gonna, of course, as usual, open the meetup RSVPs and 3 weeks before, and then yeah, tweet and write some details on that. And thank you to our sponsors, Tyke and JFrog and GoBridge. And yes, I think that's it. That's the last slide. So thank you again. Thanks to our speakers. Thanks to everyone on Zoom and on YouTube that has been watching us. Yeah, thank you again, and see you. We'll all see you next month, hopefully. Cheers. Bye.
Thank you. Goodbye.
Bye. Bye-bye.